So in this section, we'll talk about functions. And we'll talk about what functions are in a minute. But first, let's talk about relations. A relation is a set of any set of ordered pairs. The set of all the x components of the ordered pairs is called the domain. And the set of all the y components is called the range. So let's look at this one. Find the domain and range. So we'll talk about the domain first. The domain is the x components in these sets of points. So here's an x, here's an x, here's an x. Remember, each point is x and then y. xy, xy, xy. So the domain on in this case would be 98.6, 98.3, and 99.1. We write it as a set, so that's why we have the squiggle braces at the end, commas in between each piece. The range is the y parts. So that's here, that'd be Felicia, Gabriella, and Lakeisha. Again, it's a set with commas between each. A function is a specific type of relation. It's a relation where each item in the domain is matched with only one item in the range. So for instance, this table represents a function. The things that are in the first column would be the domain. So sitting, walking, aerobics, tennis, running, and swimming. The calories burned would be the range. So we'd have 80, 325, 505. And if it number or in the domain or range is repeated, we wouldn't write it more than once. You just write it once. 720 and 790. So sitting goes with 80, so we could draw an arrow here. Walking goes with 325. Aerobics goes with 505. Tennis goes to 505. Running goes to 720, and swimming goes to 90. This is a function because everything that's in the domain is matched with only one item in the range. It's okay that aerobics goes to 505 and tennis goes to 505. It's okay that they go to the same thing because aerobics is still only going to one number and tennis is only still going to one number. So let's look at this. We'll find the domain. We can put it in a circle. I think that might make it easier this time. 1, 2, 3. And the range would be the second numbers, 8, 9, 10. And because 1 is with 8, that's saying 1's going to 8, 2's going to 9, and 3's going to 10. So yes, this is a function because every item in the domain is going to one thing in the range. Okay, so let's do this again. So domain, you can see that the 2 is listed 3 times. We're only going to list it once because if something's repeated, we don't list it more than one time. But the range is 3, 4, and 5. And in this first point, it says 2 is going to 3. And the next point says 2 goes to 4. The next point says 2 goes to 5. So in this case, our domain number is going to 3 different numbers in the range. That cannot happen in a function. So this is not a function. It's still a relation. Relation is general. Function is more specific. So here we have 3, 4, 5 for our domain. And for the range, you can see we have 6 all 3 times. So we'll just write it once. And here the 3 goes to 6, and then 4 goes to 6, and then 5 goes to 6. So here we have each item in the domain going to one thing in the range. It doesn't matter if it's the same thing, it just can only go to one thing. So yes, this is a function. So it's okay to have domain items going to the same thing in the range, but it's not okay for the domain to go to more than one thing in the range. An equation represents a function if there is only one y value for each different x. So the first thing you have to do is solve for y. So let's look at this equation. We have x squared plus 2y equals 10. And if I'm trying to get y by itself, solve for y, I need to move the x squared first. So I'll subtract x squared from both sides. And that leaves me with 2y equals 10 minus x squared. Then I would need to divide both sides by 2. So I get y equals 10 minus x squared over 2. So the idea here is if I stick a number in for x, will I get out only one value for y? Will it always be the same answer that I get out for y, or could there be different answers for y? In this case, no matter what you pick out for x, there's only one possibility to go with that x in the y spot, which means that this is a function. So let me show you what something is not a function. This will help make it clearer, I think. So we're going to solve for y again. I'll just write a little bigger. So again, if I want to get y by itself, I need to move the x squared first. I was going to cancel that out. So that leaves me with y squared equals 16 minus x squared. And now I need to get the y by itself. So I need to take the square root. But remember, we did in chapter 1 that if you solve a square root, you need to take the positive and negative square roots. So on the y side, it cancels out, and it just leaves us with y. But remember, we talked about how this really is 2 different answers. This is really the positive square root of 16 minus x squared, and y is equal to the negative square root of 16 minus x squared. So that means if I choose something for x and I plug it into this problem, there's 2 possibilities of y's answers. And that means that this cannot be a function. You can only have one answer in only one y answer. So functions can be written in a specific way because they're really important. And we write them like this. And we read that as f of x. So it doesn't mean f times x. Those parentheses are not multiplication. So what this is really saying is that f is the name of the function. X represents the number that's being put into the function, or we also call it the independent variable. And f of x is the value of the output of the function. We can also think of this as being y. So it's a little bit like we have a machine. Okay, functions are just rules or machines. And the machine is called f in this case. You put in an x, and you get out f of x or y. So here, when it says f of 3, it's telling us that x is equal to 3. And at this part, where it says f of x is equal to 2x squared minus 4, is telling us that f has this rule of 2x squared minus 4. So if we think about that machine, it's telling us that whatever we put into the machine, this function is going to take it, square it, multiply by 2, then subtract 4. So in this case, we're going to put 3 into it because it says find f of 3. So f of 3 means that we'll replace x with 3. And when we do that, it's a good idea just to get into the habit of always replacing that number in parentheses. So f of 3 means we just need to simplify this. You can type it into your calculator all at once just like you see it, or you can simplify it. If you do simplify it, you have to do squared first. So 3 squared is 9, times 2 is 18, minus 4 is 14. So the answer is 14. So let's do another one. So this time it says f of x is equal to 9 minus x squared. So this is also going to be replaced here. This problem wants us to find f of negative 2. So negative 2 is the number we're going to put in where we see an x. So you could just write the whole thing again, just putting parentheses where the x was, and put negative 2 in those spots. So f of negative 2 would be 9 minus, you have to do this part first, so that'd be 9 minus 4, which gives us 5 as our answer. Now you could, if you wanted to, type the whole thing into your calculator all at once, and that's probably safer. Okay, so now let's look at this problem. This says f of x is equal to x squared minus 2x plus 4. So this says that here's an x, here's an x, and here's an x. So whatever is right here is going to have to be put here and here. So if I want to find f of, oh yeah, I could do this again. That probably is, I like to do this because then it shows me exactly where I'm putting whatever's in this parentheses. Every place there was an x, it's like I'm just erasing that x and putting parentheses in there. And that's really what functions are doing. So in this case, we're putting in x plus 2. So we have x plus 2 in parentheses squared minus 2 times x plus 2 plus 4. And we need to simplify that. So the first thing we need to do is recognize that this, when we have it squared, really means x plus 2 times x plus 2. I'll just copy the rest of it for a second. So here we want to, in order to multiply it together, we have to distribute. So we'll take this x times both of those, which gives me x squared plus 2x. And then we need to take this 2 times both of those, which gives me 2x plus 4. Here we need to take a minus 2 times both of those, so we get minus 2x minus 4, and then plus 4. And then we just need to combine like terms. So we would get f of x plus 2 equals, there's no other x squared, so I just write x squared. Here's 2x plus 2x minus 2x. So that gives me just a positive 2x. And then 4 minus 4 plus 4 is just plus 4. So that's our answer. X squared plus 2x plus 4. So this says, is f of x plus f of 2 the same thing? So let's find f of x plus f of 2. So remember last time we found f of x plus 2, where it was in parentheses. This time it's split apart. So f of x tells us right here that that is x squared minus 2x plus 4. So let's find f of 2 first. So f of 2, again, means that I'm taking this, but every place there was an x, I'm replacing it with 2. So I have 2 squared minus 2 times 2 plus 4. 2 squared is 4 minus 4 plus 4, and we just get 4. So this plus sign would still be here, and then 4 is this part, because we got it right here. So I'll just simplify. We get x squared minus 2x plus 8 for this answer. And no, they're not the same thing. You can see that what we got in part A did not match what we got for part B. So when you have a function with something like added or subtracted inside the parentheses, it's not the same as splitting it apart. You can't distribute because it's not multiplication. So let's look at negative sign here. So again, I'll start by writing my function out. I'm going to leave parentheses every place there was an x. And inside those parentheses, it tells me to put a negative x. Okay, so I'm going to simplify this. When we have a negative x squared, that really means negative x times negative x, and that's a positive x squared. Here's this negative 2 times positive or negative x, which gives us a positive 2x plus 4. So this is our answer. Part B says, is that the same thing as having a negative f of x? When we have a negative in front of f of x, it really is just saying that we're going to have a negative in front of f of x, the whole thing. And when we have, so it's like putting this whole thing in parentheses there, if you want to think about it like that. When we have a negative in front of parentheses, we have to distribute that negative. So we get negative x squared plus 2x minus 4. And that's not the same thing as we had just a minute ago. So again, where the negative is matters, whether it's outside or whether it's inside. Okay. Remember that the value you get from a function is really a y value. Okay, so we're going to graph this function by making a table. So we'll just choose 3 things for x. I like to use 1 negative, 0, and 1 positive. Okay, so this is my x, which means that when I stick it in, I'll have 3 parentheses, whatever that number is, negative 2 here, minus 1. So this is negative 6 minus 1 is negative 7. Then I would have 3 parentheses minus 1. This time I'm putting 0 in. 3 times 0 is 0, minus 1 is negative 1. And then 3 parentheses 2 is 6 minus 1, which is 5. So I'll graph that. And then this right here is a point. It's the point negative 2, negative 7, because this is really the same thing as y. The next point is 0, negative 1, and the next point is 2, 5. So -2, -7 would be clear down off the page, really. 0, -1 would be right there. And 2, 5 would be right here. So if I had to graph that, I would draw a straight line that connects those points. We'll stop and do a second video for the rest of this lesson.